Hello guys, welcome back to the QST channel. Today I will be doing the section 4.3 quiz for the IGCSE math periodic. Let's start. A particle moves in a straight line so that its displacement s in meters from the fixed point O after t seconds is given by s equals t cubed plus 3t squared plus 6t. When is the particle at rest? When they say when is the particle at rest, they basically mean the particle is not moving or its speed is zero. يعني its velocity is zero basically. So we need to find the velocity and make it equal to zero. How do we do that? They gave us the displacement equation function, so you derive it to get the velocity. So v equals to, remember to derive, you bring the power down and minus by 1. So t cubed will become 3t squared. 3 minus 2 is 1, and I mean what? 3 minus 1 is 2, plus 3t squared, you bring the 2 down, it will be 2 times 3, 6, and then it will be t, then plus 6, the t will go away. Okay, now they want it equal to 0, so all of this equals to 0. We can factor this by 3. You will get 3t squared plus 2t plus 2 equals to 0. You divide 3 by both sides, you just get t squared plus 2t plus 2 equals 0. Now this equation, you can't factor it, and if you try to solve it any other way, it will not work. See, I'll show you. If you try to use the quadratic equation, you will get it wrong. Let's try. Okay, negative 2 because negative b plus minus radical b squared minus 4ac, so 4 minus 4 times 1 times 2, which is 8, over 2 times a, which is 2 times 1. You'll get, in the radical, it's going to be radical negative 4. And when you have a negative in a radical, you cannot solve it. So basically there's no solution to this equation, which means that there is no time when the particle is at rest, so you choose that option. Don't be tricked when they say select all that apply. Oh, and when you use the calculator for the previous question, you'll get something plus something I, and we didn't take that yet, so whenever you see I, just ignore it. It means no solution, no real solution. Okay, a particle is moving along the x-axis so that at any time t seconds, its position from the origin O is given in meters by xt equals to 2t squared plus 8t minus 5. The average acceleration of this particle between t equals 3 seconds and t equals 5 seconds is a meter per second squared. What is the value of a? Okay, for the average acceleration, the rule is v final minus v initial over t final minus t initial. We have the time, it's 5 and 3, so 5 minus 3. Now to get the velocity, they gave you an xt function, the displacement. So to get the velocity, you derive it. So vt equals to 4t, you bring the 2 down, plus 8, then negative 5 is a constant, so it will become 0, so 4t plus 8. Okay, now we need to find the velocity at 5 and the velocity at 3. So velocity at 5 is equal to 4 times 5 plus 8. 4 times 5 is 20 plus 8, 28. Then v3 equals to 4 times 3 plus 8. 4 times 3, 12, plus 8 equals 20. Now we have both of them, we can solve. Okay, the average acceleration is 28 minus 20 over 5 minus 3. So it will be 8 over 2 equals to 4. meter per second. A traveler left home at 7:30, drove for a while, and then returned home. The diagram below describes the trip. The average speed during the time interval 8:30 to 9 is y km per hour. Find y. Okay, when they give you a graph and they want average speed, when they give you distance time graph and they want average speed, it's just the slope. So you just have to find the slope between 9 o'clock and 8:30. Let's find it. So you do y2 minus y1 over x2 minus x1. At 9 o'clock, here it's 180. Since between 200 and 160 is 180. So 180 minus, at 8:30, the distance is 120. So minus 120 over. The time is 30 minutes. And since they want it in kilometer per hour, so make it in 2 hours. So 30 over 60. It will be equal to 60 over 1 over 2. So 60 times 2 equals to 120. Or you can just plug it in the calculator. You'll get 120. A particle is moving along the x-axis so that at time t seconds its displacement from the origin is x meters, where xt equals to 8t squared minus 5t plus 13. Its velocity when t equals t 2 seconds is p meter per seconds, where p is a whole number to be determined. What is the value of p? Okay, when they want a velocity at a certain time, they didn't tell you like between 2 and 4 seconds. They just said 2. So you find instantaneous velocity, which means you don't do x final minus x initial. You derive and then you substitute by 2. So basically, derive this, you will get vt equals 2. Bring the 2 down, 16t minus 5. Now they want the velocity at 2, so just substitute by 2. v2 equals to 16 times 2 is 32 minus 5 is 27. So that's the answer. A particle is moving along the x-axis so that at time t seconds its displacement from the origin is x meters, where xt equals to 1 over 3t cubed plus 4t minus 4. The average acceleration during the first 2 seconds is a meter per second squared. Blah blah. What's the value of a? Okay. So they want average acceleration during the first 2 seconds. Average acceleration is v final minus v initial over t final minus t initial. Okay. So let's write v final minus v initial over the time. They told us first 2 seconds. It basically means the final is what? The final is 2, and since this it's the first 2 seconds, so the initial is 0. So it's 2 minus 0. Here it's v2 minus v0. Okay, they give us the xt graph, so we can derive and find the vt graph. They give us the xt equation, so then you can derive to find the vt and then substitute to get each value and do the average acceleration. Okay, so derive this, it will be vt equals to 3, bring it down, 3 times 1 over 3 is 1, so it will just be t squared plus 4t to become 4, and negative 4 will not be there. So find v2, it will be equal to 2 squared, which is 4, plus 4, which is 8. Then v0 is equal to 0 squared 0 plus 4 is 4. So average acceleration will be 8 minus 4 over 2. It will be 4 over 2, which is 2. Okay. A particle moves in a straight line so that its displacement s in meters from the fixed point O after t seconds is given by s equals t cubed minus 5t squared plus 20t plus 1, where t greater than 0, greater than or equal to 0. The distance the particle travels during the third second is what? Okay, when they say the distance traveled during the third second, they mean the distance between 2 seconds and 3 seconds. Like, to explain this, if you say you had a distance of 14 meters at 2 seconds, and then at 3 seconds you had distance of 24, so that means during the third seconds you increased by 10, which means the distance you traveled during that third second is 10, which is the difference between 3 and 2. So what we need to find is the third second and the second second, and then subtract them. So they give us a displacement graph, so you just substitute here. So s equals to, at 3, so 3 cubed minus 5 3 squared plus 23 plus 1 to be equal to 27 minus 45. Okay, I'll just do it on the calculator. You will get 43. Okay, that's for when the distance is at 3, and then the distance at 2, it will be, again on the calculator, you will get 29. So 43 minus 29 equals to 14. So the distance traveled is 14. Particle moves in a straight line so that its displacement s in meters from the fixed point O after t seconds is given by s equals t cubed minus 5t squared plus 20t plus 1. The time when the acceleration is 14 is what? Again, this one, like the other question, they give us one value. They told us when the acceleration is 14. So this is instantaneous, not average. So first let's find the equation for acceleration and then make it equal to 14. So how do you get that from the displacement one? First you derive it to get velocity. So you will get velocity equals to 3t squared minus 10t plus 20. Okay, now derive it again to get acceleration. So acceleration equals to 6t minus 10. Now they want when the acceleration equals to 14, so you do 6t minus 10 equals to 14. Add 10 on both sides. 6t equals to 24, t equals to 4. Okay, this came in a previous AMS, but I'll do it anyway. The average speed between 9:30 and 11:30 is what? Average speed is x final minus x initial over t final minus t initial, or simply the slope, but it's the same thing anyway. So at 11:30 it's 300, so 300. At 9:30 it's 150, so 300 minus 150 over between 9:30 and 11:30 it's 2 hours, so it's 2, since they want a kilometer per hour, so it will be 150 over 2 equals to 75 kilometer per hour. For the second one, at 9:30 it's 150 minus at 7 it's 0, and then between 7 and 9:30 it's 2.5 hours, so 2.5. You will get 60. Okay, this is same repeated question. The maximum speed is what? They give us the distance and they give us the graph. The distance, we know it's the area under the graph, and the area under the graph here is a trapezoid. So we use the rule big base plus small base times the height over 2 for trapezoids. So you make that equal to 63. So 63 equals 2. What's the big base? 7 to 8 is 1 hour. Again, they want it in kilometer per hour. So 1 hour plus 705 to 750 is a small base. It will be 45 minutes. So 45 over 60 in hours. Times the height is v, which we want to find, over 2. You'll get 126 equals to 1.75 v. Divide 126 by 1.75, you'll get 72. Then the average acceleration during the first 5 minutes is what? Average acceleration v final minus v initial over t final minus t initial. V final is 72 from here, minus 0 because it's the first 5 minutes. Then the time is 5 minutes, but they want an hour, so 5 over 60. You will get 864. Thank you for watching this video. Wish you luck in your exams. Goodbye.